Hey, it's Sue, and today we're going to talk about polar graphs. This is in your notes in 9.3, and this is really a review of some pre-calc. So the first thing we want to talk about is the polar plane, and that's easy because the polar plane is exactly the same as the xy plane. You can even see here there's the x-axis and the y-axis. The only difference is how you describe the points. So if you have a point over here, with Cartesian, you would describe it with the x and the y. How far over, how far up. That's your x and your y. But in polar, you describe it a little differently. You think about a rotation. So from the positive x-axis, you describe how far you've rotated it, what angle did you use, and how far out. So this is your theta, and this is your r. So any point can be described with a theta and an r. When you write those down, it's r theta form. Okay? So we should be able to graph them, so let's practice this. If you'd like, you can try practicing graphing these points, or I'll do it for you. Okay, so if we're going to plot polar points, we have to make sure we know the scale of this graph. So if you count, you can see that there are 1, 2, 3, 4, 5, 6 subdivisions between 0 and pi over 2. So each one must be pi 12ths. So I'll label a couple of these. All right, so let's try to plot these points. So if you want to graph point A, I usually first try to find the angle. So it's as if you're standing at the origin, facing east, the positive x-axis, and you rotate 2 pi over 3 counterclockwise. So if you go around 2 pi over 3, and then the radius is how far out you go. So you go out 2 units, 1, 2, and this is point A. Okay. You can try the other ones. For part B, you'll notice that you're still using the same angle, 2 pi thirds, but your radius is negative now. So if your radius is negative, it's like you're walking backwards. So here's your 2 pi over 3 line, which goes all the way here. And so we'll walk backwards 2 units, 1, 2, and you end up here for B. So a negative radius, you're walking the opposite direction. All right. For part C, we need to find where pi fourths is. And we go out 3 units along pi fourths. 1, 2, 3. For point D, you have to find where 9 pi fourths is. In order to find 9 pi fourths, you need to do a full rotation plus another quarter. So actually, 9 pi fourths is coterminal with pi fourths. So point D is actually the same as point C. This happens, you may remember that in polar, there's more than one way to name a particular point. So it has multiple representations, which can make it a little more complicated. For part E, you have a negative angle this time. That's easy. Negative angles just means that you go clockwise instead of counterclockwise. And a positive radius, so I go out 1, 2, 3, which might be... And point F is another example with a negative radius. So that's pi fourths, but a negative radius, so you go in the opposite direction. And there's part F. So that's point plotting. In addition to that, you should be able to know some relationships between the xy coordinates and the polar coordinates, and these are relatively basic. So if you have a point where this is your r, and this is your theta, but this is also your x coordinate, and this is your y coordinate, there's some easy relationships here. So, for example, this third one, r squared is equivalent to x squared plus y squared. That's your Pythagorean theorem based on your right triangle here. Tangent of theta, opposite over adjacent, is going to be y over x. And to write x and y, you may remember that cosine of theta will be x over r, which means that x is equal to r times cosine theta. Similarly, your y coordinate is equivalent to r times sine theta. These are pretty basic, but they're worth knowing, and you should either be able to recreate them very quickly or have them memorized. Okay, the next part is we should be able to graph polar functions. So let's look at that.